So here we are again with our heart with two different sides, the right and the left. And it also has two different chambers from the top and the bottom, which are the atria and the ventricles. Normally, the right atria pushes blood to the right ventricle, and a little bit of blood comes back from the ventricle to the atria. This is called regurgitation, and an ultrasound can often measure this regurgitation and tell you the speed of it. You can then compare points 1 and 2 in the heart, so that's in the right ventricle and the right atria, and by using the ultrasound velocity, find something out about the pressure drop. So the velocity is being measured, and you can find out if it's big or not. And then we know that the height is fairly negligible. They're pretty close to each other in location. And then the pressure is able to be found from the Bernoulli's equation. So here we have that point 1, pressure plus rho v squared over 2 plus rho gh on the left is equal to the same at point 2 because they're all along a streamline. Now, if you consider those heights to be negligible, you cancel out the rho gh terms. We know the velocity at point 1 thanks to the ultrasound, and we know the velocity at point 2 is 0. And then you can rearrange the terms there and find out from the velocity the pressure drop across point 2 and point 1. This is extraordinarily helpful for doctors who are trying to tell if the valve between the atria and ventricles is functioning properly. From this pressure difference, they can find out whether the valves need to be replaced and if they can even be replaced with mechanical valves.